Look at modeling with linear functions. These are applications of linear functions, so story problems. I don't think, no reason to get intimidated. Anytime you're reading application problems, whatever type they are, so some basic things to be looking for. First, identify what variables are involved in the problem. What are we being asked to find? What's changing? What's unknown? Second thing we want to look for is what information is given in the problem. What's fixed? What do we know for sure is going on? And then we want to relate what we know and what we want to find. Some good techniques to try: making a table to organize the data, drawing a picture to illustrate what's going on in the problem. Many of us are visual learners. Identify whether a formula might apply. Distance equals rate times time, the Pythagorean theorem, any of those formulas. Area equals length times width. And always read and reread the problem, identify that critical information, cross out any excess information that doesn't really apply to the problem, and always pay attention to the units being used. Sometimes a problem will be talking about both minutes and hours within the same problem. And converting all those units in the same type of unit, everything into minutes or everything into hours, may help eliminate some confusion. So our first example, you're going to borrow $3,500 from Grandma to finish up your last term of college. After graduation, you're going to pay her back at $50 per month. So you want a linear function for how much you still owe her T months after graduation. Find and interpret that horizontal intercept. So I'm playing around with the problem a little bit. We're starting off, we have a debt of $3,500 to Grandma. And we're going to pay her back $50 every month. Now, this isn't the most efficient way to solve a problem. Playing around with a problem like this gives us an idea of what's going on. We're starting off with a debt of $3,500 and is going down by $50 every single month. And so that can lead us to the model. It is a linear model. And so what we still owe Grandma would be our output. So let's use the variable D for debt. The input is the number of months since we graduated. So we could use M, or how about T for time. So we can describe the debt, the amount we still owe. It starts off with $3,500 and it decreases 50 times the number of months that have gone by since graduation. The horizontal intercept is going to be the value of T when D is 0, the value of the input when the output is 0. So to find the horizontal intercept, what we're finding is how many months will it take to pay our debt off? How many months until the debt is 0? Solving the equation, we end up with 70. It will take 70 months to pay off the debt. Always with application problems, finish the problem, think about what units are involved, answer in terms of the problem, including units. See if everything sounds reasonable. Another example, you're on vacation, decide to rent a bicycle and do some exploring. You go outside your hotel, you see there's 2 vendors with bicycles to rent, and they've got their rates posted. Best Bicycle is going to charge you $3 to rent a bike, and then an additional $1 for every hour you have the bike out. Cycle Cruising will charge you $5, a higher fee, but only 50 cents per hour. So we can tell that if we're not going to rent the bike for very long, Best Bicycles would be the better price because of the lower fee. Whereas if we want to rent the bicycle and take a long day, Cycle Cruising would probably be the better deal because of the lower price per hour. So at what point, how many hours will it be when Cycle Cruising will be the better buy than Best Bicycle? So we've got 2 separate linear functions for each of these vendors. So for the Best Bicycle, we have a charge of $3 plus an additional $1 per hour. And for cycle cruising, their fee structure is $5 plus an additional 50 cents per hour. So a couple ways we could look at this problem. We could graph each of these functions and see where they cross. This is going to be a very crude graph here. So for best, we're starting at $3 and going up with a steeper slope of $1 per hour. For cycle cruising, we're starting at a higher vertical intercept of $5, but we have a more gradual slope. And we can see there's going to be a value here, where this is a number of hours, and this is the total we're being charged, where the two lines intersect, and for that number of hours, there'll be the same charge for both. If we're lower than that number of hours, then the black line, best bicycle, will be the better deal. If we're above that line, above that point, renting the bicycle for more than that number of hours, then the red line, cycle cruising, will be the better bet. So what we can do is take these two equations, set them equal to each other, and we can find the point in time, the number of hours, when they're both going to cost the same amount. So at 4 hours, both bicycles will cost the same. If we're going to rent the bicycle for more than 4 hours, cycle cruising will be the better buy. Okay, last example. It's estimated that in 2006, YouTube viewers watched 100 million videos a day. By 2011, that number was estimated to be 4 billion videos a day. Assuming this trend is linear, which probably is not a good assumption, I suspect it's really exponential, find a model for the number of videos viewed per day as a function of the year. So you've got some very large numbers in this particular problem. It might be helpful to play with the units a little bit. We can let, instead of using 100 million for the number of videos a day, we could just define things to be in millions of videos. And so we could say that in the year 2006, using 6 to represent 2006, there were 100 million videos, and just use 100 to represent the 100 million. So then in 2011, being consistent, we'd use 11 to represent 2011, and the 4 billion videos would be 4,000 million videos. So here, our variable x is the number of years since the year 2000, and our y value, or f of x, is the millions of videos watched per day. So using these scaled back numbers, we can find the equation of our line. So there's an increase per year of 780 million videos per year watched per day on YouTube. This would be our slope, our rate of change. Now to get our vertical intercept, our y-intercept,